Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. We've got step 1, step 2, step 3, and this is a strange one because we're not actually going to count the number of blocks. We're going to count the surface area, and I know these cubes have little holes in them and patterns. We're going to ignore those holes and patterns and just think of them as cubes. So one face of a cube would have 1 unit of surface area. And your challenge is to predict the surface area in step 4 of this pattern. And then if you can do that, can you predict the surface area in step 43? And could you write an equation to predict the surface area in any step at all? This is a tough one. If you'd like to accept that challenge, pause the video, give it a shot. Okay, so we've got a pretty interesting pattern here. This is obviously a three-dimensional shape. It looks like we're adding a layer every time. But on the other hand, we're not talking about volume, we're talking about surface area. So what kind of a pattern is this going to be? I don't think it's going to be cubic because we're not talking about volume, but is it going to be a quadratic or linear or something else? Well, let's start by just looking at the pattern, predicting what the next step will look like, and then seeing if we can calculate the surface area of that next step. So, and actually, I think I want to calculate the surface area of each step as we go along here, just so we're all on the same page from the beginning. We've got one layer here of 8 blocks. So it's a 3 by 3 square of blocks, but with a hole in the center. And then in each step, we add, looks like one more layer each step. So if I think about surface area, I can think first about the top. And I've got 3 blocks right here and another 3 right here, and then 2 more. So that's 8 squares of surface area on the top. I'm going to jot that down. On the bottom, I would have exactly the same thing. So that's another 8 on the bottom. And then I've got to go around the sides. We haven't covered those sides yet. So I've got 3 and 3 more and 3 more and 3 more. That's 12 around the side. And I'm not done yet because this counts too. So there's these 4 inside squares that face the hole. So plus 4 more. So 8 and 8 and 12 and 4, that's 32. Okay. Now, when we add a layer, something interesting happens. We cover up this previously exposed bit of surface area, but then we put another layer of that on the top. And as this gets taller and taller, the top and the bottom are going to stay the same. That's always that 8 plus 8. And then each layer should have the same pattern of outside and inside, right? So each layer, the outside is exposed, the inside is still exposed to the hole. So that should be, well, 12 plus, I'm just going to write that as 16 for one of the layers and 16 for another of the layers. And we'll get the same pattern here, that top and the bottom, and then the 16 plus 16 plus 16. So for step 4, I would have the top and the bottom, and I'd have 4 layers of the 16. And remember that 16 is the outside and the inside. Okay, so that should be it, right? So 16 times 4 is 64, and another 16 would be 80. So I think we're going to have 80 units of surface area in step 4. All right, let's try analyzing these numbers. These numbers are getting pretty big. We're going to make a chart with the step and the surface area for each step. So in step 1, we said 32. In step 2, yeah, we're just basically adding 16 every step. So 32 plus 16 would be 48. And in step 3, then, that would be 64. And in step 4, we're predicting 80. If we take the difference, it probably won't surprise you. 48 minus 32, 16. 64 minus 48, 16. 80 minus 64, 16. So we're adding 16 every time. This is actually a linear pattern. Even though we're dealing with a 3-dimensional object and we're dealing with area in terms of the surface area, that surface area grows at a linear rate because this difference is constant. So we can use the formula for a line, y equals mx plus b, to model that. And what goes in for m, the slope of the line, is this rate of change, how much it goes up every step. So y equals 16 times x, and x is the step number. And the b here, well, let's figure out what that would be. It's whatever else we have to add to make it work out. If I have y equals 16 times step 1, that would only get me to 16. It would actually only cover, well, this much. And then we'd add the top and the bottom. That's another 16. And y equals 16 times 1 plus 16 would be 32. And that's how many we have in step 1. Let's try that in step 2 just to make sure. So y equals 16 times step 2 plus 16. And that's 32 plus 16. Yeah, that's 48. And you can try this with step 3 and step 4. I think you'll find it works out. So this equation, y equals 16 times the step number, or 16x plus 16, is our equation for this pattern. Now, to calculate the amount in step 43, the surface area in step 43, we'd just plug in 43 for x. So y equals 16 times 43 plus 16. Okay, 16 times 43. I'm going to do this in a couple of steps. I'm going to see 10 times 43 is 430. And then 6 times 40 is 240. And 6 times 3 is 18. That should give me 16 times 43. So that's 688. And now I need to add 16 more. And I'm getting 704. So 704 units of surface area in step 43. Well, how did that go for you? Did you get the same thing I got? Did you get 80 for step 4? Did you come up with an equation like this? This was a really difficult one. Let me know how it went. Thanks.